Hello, Dennis Madden here, and welcome to another edition of Gears Overdrive. This time I'd like to talk about what I call hidden sensors. Now, there's really no such thing as a hidden sensor. It's not something that you can't get to, or it's buried somewhere, or you can't see it. What I mean by hidden sensors is a sensor that may be delivering bad information, but the computer's okay with it. And consequently, it'll take that bad information and cause the transmission, or the computer, I should say, to result in shift complaints or any number of drivability problems. Now, in the article, I highlighted 5 sensors that fit this description. It's not limited to 5, but I gave 5 as an example. Now, before we get into these, I want to just emphasize something that is pretty common sense. And when you think about it, these hidden sensor problems become easier to understand. The idea behind the automatic transmission is to duplicate the shift movements a driver will take when they're operating a standard transmission. Which gear they're in, the application of the clutch. It's going to vary whether they're going around a turn, up a grade, down a grade. There's any number of shift variations or driving variations that will modify what a driver does when they're operating a standard transmission. Well, over the years, engineers have tried to duplicate that. One of the most recent sensors that I find very fascinating, and matter of fact, in this September edition of Gears magazine, Steve Garrett covers this sensor. It's a brake pedal position sensor. And the fascinating thing about it is it's not just is someone pressing on the brake or not, but how hard are they pressing on the brake? What does this do? It lets the computer know if perhaps you're going down a grade, right? Perhaps it's some type of performance driving that you're doing. Any number of things that the computer will see that the driver is pressing on the brake harder or lighter, and will change what it does to the transmission in terms of what gear it's in, how hard it's going to shift, so on and so forth. I commented on this next one in another video short, the steering angle sensor. This is becoming increasingly important to drivability because the computer wants to know, is the customer turning a corner? Now, every time you have your front end aligned, the technician doing the work is supposed to recalibrate that sensor so that the computer knows when it's going straight ahead, and then it will deviate as it watches the steering wheel move through that sensor. All designed to understand, what is this customer doing, or this driver doing rather? Are they turning around a turn? Something else though that can confound the computer with regard to this is tire size. We have seen examples of wrong tire sizes where a customer may have a flat, they put the spare on, or they put something that fits. It may have been put in the trunk through the used car lot, and it doesn't belong with the car, but it fits the car. Any number of things that can put you into this example, and that is because of the different tire size, one wheel is spinning faster than another, and the computer interprets that as going around a turn. And a range of shift complaints can occur. So erratic shifts, harsh shifts, any number of complaints. Take the time to look at the tire sizes, make sure they're all the same, and think like a driver of a standard transmission. Are you trying to make a turn? Because the computer will interpret that and operate differently. The next sensor that I used in the article, or talked about in it, is the knock sensor. Now, it doesn't directly have anything to do with transmission function, but it does have to do with engine performance. So it's a listening device. And what it's doing is it's listening for detonation in the engine, premature detonation. It can occur because of bad gas or any number of mechanical problems or engine-related problems. And if the sensor goes bad and is signaling a knock is occurring when it isn't, or even if it is occurring, it doesn't really matter. One of the common things that it will do is disable overdrive. So you could have a customer come in with a no overdrive complaint, and guess what? It's because of the bad gas they used down the street. The engine detected, or the computer detected a knock in the engine. It retarded the ignition, the power is down, and consequently it's going to not go into overdrive. And it could be as simple as that. Now, there are ways that you can check this on your scan tool. I'm not going to go into the detail of that particularly in this article, but I want to make you aware of systems like this that can cause transmission complaints where there is nothing wrong with the transmission. Another one is a shift mode switch. Now, you've seen this as things like tow haul switches, for example, or traction control. In the example I have here, a traction control, this is a Cadillac Seville. And it's kind of interesting where they put this switch. It's right in a convenient place for someone to put their purse. And this is an actual instance where someone put their purse on the console, hit the button, and it was making second gear starts. Put the purse on it again, release the button, and now it's driving normally. So get the detail from the customer, specifically what the complaint is, and make sure that you operate all of the traction control and mode switches to make certain that they operate correctly, that they're not turned on when they should not be. You may even want to inform the customer of that, particularly if it's in a crazy spot like the image that we saw there. So very important to your diagnosis, and the computer is just fine with taking off in second gear. In fact, it's programmed to do so. And lastly, the O2 sensor. This is a little tricky, and the computer has a wide range of leeway for this. And you'll have to get into some pretty serious diagnosis to track this one down. ATRA has some wonderful articles on diagnosing O2 sensors. Some of that uses a scope. The key point here is that the O2 sensor, or I should say the computer uses the O2 sensor to determine the fuel-air ratio coming out of the engine, and it will modify the fuel going in to get the best output. And an O2 sensor that has failed or is on the brink of failing may not set a trouble code, but can have engine performance issues that result in a change on how the transmission operates. So these are just a few of the hidden sensors that are detailed in this article. Just be clear on this, not everything sets a trouble code, so ask more questions and be more observant, and you'll be far better off in your diagnosis. If you'd like to see more of these video shorts, make sure you hit the subscribe button. This is Dennis Madden. We'll see you next time.